in a few minutes. Okay, all right. So first, let's get started with 11D. So you just need to memorize this, okay? Just need to memorize this. Now let me break this one down for you. So this is integration by substitution, okay? And now this one, the idea is that when you antiderive, okay, so when you antiderive a function fu, right, a function of u, and then inside that you are multiplying that by, this is the key, du over dx. Yeah. All right, so the derivative of u with respect to x, and then everything is with respect to x. So you say this is a function of u, right? But you want to derive it with respect to x. In order to do that, you need to have a du over dx inside it, and then that would be the equivalent to antiderive of fu with respect to u, which is straightforward, right? Think about it, like if this is the same as the one that it is with respect to, you just antiderive as normal. Yeah. Okay, so this rule is the idea that if you can replace a complex expression of x with just a single letter u, how do you change it from with respect to x to with respect to u? You see it? Yeah? The key here is you want to change, instead of with respect to x, you want to change it into with respect to u. All right? Okay? Okay, right. Let me give you a few examples and then hopefully it makes a bit more sense. Okay, let's say have a look at example number 9. All right, so the idea is that, let's say if you're trying to find, so question A, if you're trying to antiderive sine x cos squared x, right, or I'll rewrite it as cos x everything squared, okay, with respect to x dx. Okay, the idea is that you need, if you can see that this is the derivative of, or it can be it's similar to the derivative of what's in the brackets of this function here, right? This is the function of x, but you can turn this on into a function of u. And if this is similar to your, if you can turn that into your du over dx, then you can simplify the expression a lot better. So for example, let's see, if I see that, I would go let u equals to cos x. Okay, and then instantly find out what du over dx is, and this would be negative sine x, right? Yeah. Yeah. Remember the formula? You want du over dx in the main expression. So this one is a function of u, and then this is du over dx. So to remember the formula, just remember you want du over dx, so that the dx here will cancel with the dx there, sort of, right? So it sort of cancel, and you're left with just the du. Yeah, so that's what you want. You want a du over dx in the expression, right? So that the u expression will just become antiderive with respect to u. So this is called a variable changing rule or something like that. Now, so given this one here, so note that, see, this is du over dx, right? It's very similar but not the same. How do we turn it into the same thing? You multiply it by negative 1, yes. So that would be negative of antiderive negative sine x. Yeah, and instead of cos x, I already said u is cos x, so that would be u squared dx. So you see, right now I can't derive it yet. I can't antiderive it because this is still with respect to x and this is u. I want to turn this into with respect to u, du, right? And look, this is already the same as that. So then the next line, so that would be the same as antiderive of u squared. I'll swap it around, so this one would be du over dx and then dx. You see where I'm coming? Yeah. Yeah, and bam, you applying the rule, that would be antiderive u squared du. Okay. And at this point, it's easy, right? It's just like antideriving x squared dx. So u squared du is just 1 over 3 u cubed plus c.
You keep it in u's, you don't substitute the cos in?
Not yet. Now I substitute it back in. So that'll be negative 1/3 and then cos cube x plus c.
Oh, that makes sense.
That make sense?
Yeah.
Yeah. So the trick is to have the du over dx expression inside. So whatever it is, right? You want to have that inside the expression that you need to antiderive, right? And then you can move it around, so that will turn into this thing here, right? Right. So if it is in the same structure as this one here, that part becomes just du. Okay. Okay. So change with respect to x to with respect to u. So now let's try question B. So that was example 9, question A. So let's try question B. Okay, so let's try question B here. Antiderive B. Antiderive of 5x squared and then x cubed minus 1, everything to the power of 1/2 dx. Alright. Now, what do you think u is?
X cubed minus 1 brackets a half.
No, it's just x cubed minus 1. Remember, if you
yeah.
brackets a half, then when you derive it, it's a long one.
Yeah.
Alright. You just want x cubed minus 1 and then you derive it, see what du over dx is. 3x squared. How do you turn this thing into that thing?
Take 5 out and then times 3 in.
Yes, but then if you times 3, you need to divide by 3.
Yep.
Right? So that'll be 5 over 3, and inside here, then you get your 3x squared.
Ah, okay. And then the same.
Yeah? And then the other one would be u to the power 1/2.
Ah, okay.
Yeah? dx.
Yeah.
And then the steps are the same. This is du over dx, right? So then that would be 5 on 3 antiderive of u power half du over dx, which is the same as 5 on 3. So you see, this step is a little bit redundant, right? So once you've done it enough, you can sort of ignore that step there. Right? From here, you can go straight to here.
Yeah.
Yeah, with enough practice. But for now, just make sure you write the step here so you can cover the rule, the main rule here, right? Times du over dx and then times dx. Yeah, make sense? Because this one is du over dx. Right?
Yeah.
Okay, and when you get up to that point, this is easy, right? Just antiderive it. So plus 1 to the power, so that would be u to the power 3 on 2, and then divide by 3 on 2 is times by 2 on 3, plus c.
Wait, what's u again? Isn't u 3x squared?
Yeah, but you substitute it in now at the very end, right? So that would be 10 over 9, and then 3x squared, everything to the power 3 on 2.
Wait, I'm confused. Why did times by 2 on 3?
Oh, sorry, it should be x cubed minus 1. This one should be x cubed minus 1. Sorry?
Why did you go times 2 on 3?
Because I'm anti-deriving, so if you anti-derive, so this thing, right?
Oh, raise power by 1, then flip, yeah, no, makes
Yeah,
sense, yeah.
that becomes that.
Yeah, cool.
Yeah, but that's only possible because so this thing, right? This thing, that will turn into this expression here plus c.
Yeah.
Right? That is only possible because it's with respect to you.
Yeah.
Right? If it's not with respect to you, you can't actually work that out.
Yeah, cool.
Okay?
That makes sense.
Yeah. Okay. So yes. So then that would be that plus c, and you can't simplify it. U is just x cubed minus 1.
Yeah.
Okay. Now let's try C. Okay. Let's try question C over here. Antiderive of 3x e to the power x squared dx. Okay. So same thing. Let u equals to.
E to the power x?
Try again.
3x.
No.
E to the power x.
The simpler function in a more complicated function.
X squared.
Yes, is x squared. So then du over dx would be 2x.
Yeah.
Alright, then we want 2x, but this is 3x, so that will be 3 on 2, and then 2x times by e power u dx.
Yeah.
Yeah, see the pattern now?
Yeah.
Now this is du over dx, and this is dx. So then the next line, you can just simplify it. That will be antiderive of e power u du.
Okay.
Yeah, so double check with the teacher that you can skip this step here. Okay, I think it's obvious, but just double check with the teacher anyway to be sure. Because to me, it's like, oh, you already have the du over dx on this side, and then this is like the same as du over dx, so of course it's going to be just turned into du, right? So you can skip the step to just substitute that one in there.
Okay.
Right, but depending on what Sir prefer the working, you can just follow Sir's working. Right, this is just my way of explaining it, so it makes a bit more sense.
Yeah.
But yeah, so whatever Sir say, just follow Sir's instructions.
Okay.
So yeah, and then after that, antiderive it, 3 over 2 e to the power u, antiderive is the same. Right? So that's just the e to the power u, and then that will be e to the power x squared plus c.
Wouldn't it be 2x on top?
No, x squared, because u is x squared.
Oh, wait, so why do we even... Oh, okay, so yeah. Cool.
Yeah, the idea is that we change from dx to du. That's the idea. right? Because you can't. There's no chain rule. This is kind of like chain rule, but it's like the converse of chain rule.
Yeah.
Yeah. So it's a little bit tricky. Does that make sense so far?
Yeah, it makes sense. But
Yeah. So remember, this is like recorded, so you can go back and work through it later. But I'll have to go through all the examples. The later ones are tricky. Okay. So don't just sit back and relax yet. The later ones are a little bit trickier. So this is example 9, right? This is still straightforward in my opinion. And then next, example 10. Okay. This one I think not so straightforward. Let's see. Okay, so this the idea is still the same, where you need to substitute u in, but you can't substitute straight away, because if you differentiate this expression here, you get 2x plus 2, and there's no way you can times 2x plus 2 in.
yeah.
Right? So the trick is for question A. Right? For question A, the main trick is complete the square.
Oh, I hate that.
Yep, I know, but that's literally the only way for you to antiderive something like this. Okay?
Can you use quadratic formula or not?
No. Complete the square. And you see why you have to complete the square later. Alright, so question A, the only way to do it is complete the square, and I'll show you why. So let's say antiderive of 2 over x squared plus 2x plus 6, right? Dx. Okay, let's work through it bit by bit. First, turn that into, put a 2 out there, and then that will be x squared plus 2x plus 6 to the power minus 1. Okay, alright? And then you do the complete the square. But if you can do the complete the square on the side, so now let's say over here, 2x plus 6, right? So that would be x squared plus 2x, and how to complete the square, you plus what number?
Half?
No, it's half of the b value.
Oh yeah.
The square of half of the b value.
Yeah.
Because remember, what's the formula? A plus b, everything squared equals?
A
You have got to be good at this by now.
squared plus 2ab plus b squared?
Yes, a squared plus 2ab plus b squared.
Yeah.
Right? If I rewrite it as 2ba, right? So you see, this is always going to be x squared. So I can modify this a little bit. This is x plus b, right? So it's going to be x squared plus 2bx plus b squared. So the term you need to add to complete it is always half of the coefficient here of x, and then square that. So that will be half of 2, which is 1. That will be plus 1 squared minus 1 squared plus 6.
Yeah.
Yeah? Okay? So then that would be x plus 1, everything squared, and then minus 1 plus 6 is plus 5.
Okay.
Yeah? Okay? Now, so this one would turn into, so 2 antiderive of x plus 1 everything, square plus 5 everything to the power minus 1 dx.
Okay.
Okay? Make sense so far?
Yeah.
Yeah? Okay, so looking at this one, right? Again, the idea is to, you want to, okay, let me see, no, I think this one turned into tangent, right? Yeah, okay, all right. Yeah, sorry, my bad. This one, you actually don't leave it in the power minus 1. You have to put it as 1 over. So that would be 1 over 2, x plus 1 everything squared plus 5. All right, let's keep it in this form first. Okay? Okay, now, next would be you do the same thing where you want to let u equal something. So you get let u equals to the simpler function in the more complex function, which is x plus 1.
Oh, that's also the formula, isn't it?
Yes, that's right. You did your homework, okay? So du over dx would be 1, which means you don't need anything, right? It's just 1 times this thing, which is just this thing, right?
Yeah.
So you don't actually need anything. So that's why this one can simply just turn into 2. And then look, this one will be 2 antiderive of, because it's like 1 times that, times dx, and 1 is du over dx. You can simply turn the dx into du straight away. Does it make sense?
Yeah.
Yeah? And then this must be a function of u. There shouldn't be any x in it.
Yeah.
Make sense?
Okay, so of u back here.
Yeah. So the trick is to do that part, right? So once you've done that part, then you can get the next line.
Okay.
Alright, and then at this point, you already know what to do. Right? So here you want 5 on top, sorry, root 5 on top, because this will be, the bottom will be u squared plus root 5 everything squared, right?
Why root 5?
Why root 5?
Isn't it?
Because the bottom you want u squared plus a squared.
Why do you want that?
Why? Because what's the formula?
It's a over a squared plus x squared.
Yeah. A squared plus x squared. When you antiderive this, you get
I don't know.
inverse 10.
Oh yeah, negative 10 of x over a.
Yes, or vice
Plus
over
c.
a, yes, plus c, yes. So you see, this is a squared. Sorry, this is x squared, because remember, x is u, right? Now
Yeah.
x is u, and this is your a squared. And you want a on top. That's why a is root 5. It's the square root of this number.
Okay.
Make sense?
Yeah.
Because you need it in the something squared. So it's the square root of this number, and then you square it out again. So
Wow.
you want the square root in here.
Why don't we just make the top 5 and then the bottom 25? Because then it's still.
You can't,
a
because
squared.
how can you make this one into 25 without changing u?
Oh, I see.
Right? You have to
yeah.
times it by 5. But if you
Oh,
times it by 5, it will be 5u squared. You want 1
Oh,
u
'cause
squared.
you need to get it in there. Oh no, that makes sense. Never mind, I get it now.
Yeah, so you can't change the bottom. The bottom is fixed. This number is fixed.
Right.
Right?
You're trying to make it into the formula. So it's
Yes.
still
So the top is the one that has to be changed so that it matches the bottom.
Yeah, that makes sense.
Yeah. So that's why this one is root 5, because the bottom is root 5 squared. So this is root 5 on top. Okay. And that's your a value.
Yeah.
All right. So yeah, so that's why you get it to that form, and then you can just antiderive it. So that'll be 2 over square root 5 of inverse tangent u over root 5 plus c. Okay, and what is u? X plus 1. So that will be 2 over root 5 of inverse tangent x plus 1 over square root 5 plus c.
Oh, it's just is this like a build on from what like the last chapter?
Yeah.
Just a little bit more steps. Yeah, that makes
Yeah.
sense. But
The only part is that's new, that is this weird u
U,
there.
yeah.
The du over dx thing. The main part again is to change from this to that. Okay? And because u is a more complex one, right? U is a function of x. When you substitute u in, like instead of having x plus 1 squared, you have just u squared.
Yeah.
It's simpler. Okay? So to simplify it
Is
so
it
that you can
also
actually
so that it
integrate.
matches the formula as well. Is it also that?
Not too much a formula, it's just the idea that you have to replace every single x. See the x there? You have to replace it
Yeah. Okay.
so that you have a function of u. See? This is the function of u. Right? Only u in the function. Yeah? Because the formula is fu. Right? So a function of u, not a function of x.
Yeah.
Yeah. So if you have a function of x, you have to change it completely to a function of u, and then you ensure you have a factor that is the same as du over dx, and then you can change that to just simply with respect to u.
Yeah. Cool.
Okay?
Yeah.
All right. So then part B. Okay, part B is similar. So if you get part A, part B is quite similar.
This is just sine. Eh?
Yeah, that's a good guess. It is sine because you see the square root, right?
Yeah, and it's not negative on the top either.
Yep, it's not negative on the top, so that will be sine. Very good. Okay, yeah, good. I can see that you did a lot of work. Yeah. So that's the idea. It all builds on each other. You need to keep on doing these sheets, and then you'll be good to go.
Yeah.
Okay. So antiderive this dx. Okay. So again, it will be the same thing. We'll keep the 3 on top. We'll see what we get. But first, I would actually go 9 minus 4x minus x squared on this side here. Oh yeah, that's fine. Yep. And then I'll take out minus 1, so that'll be x squared plus 4x minus 9. Right? Yeah? Complete the square. X squared plus 4x plus what number?
Wait, what do you mean plus what number?
You need to complete the square. You need to get a term that will make it into a complete square.
What, 16?
No. Remember, this is x squared
Oh,
plus
half of b, so is it 2?
2, just 2.
Yeah, just 2.
What's the last term? If this is 2ba, what's the last term? Plus,
X, 2a.
plus what? This is x squared, right? This is a squared plus 2ba plus,
Yeah, 2x. 2.
what's the formula?
I don't know, a plus b squared.
A plus b, everything squared. When you expand that,
A squared plus 2ab plus b squared.
yes,
So 4.
yes, plus 4 minus 4.
Nice.
Yeah, I'll write it as plus 2 squared minus 2 squared.
Yeah.
Make sense? Because you want the b squared term.
Oh, I see.
Yeah, so the one that you need to think about is, okay, what is the b squared term that you're adding, and then you need to balance it out by subtracting. Right? So then that would be minus of x plus 2 and then squared and then minus 4 minus 9.
Yeah.
I'll use the square brackets here
I see.
to differentiate.
Sure.
Okay? Then that would be minus of square brackets x plus 2 everything squared minus 13.
Yeah.
And then you open brackets. That would be minus of x plus 2 everything squared plus 13.
Yeah.
But in order to follow the formula, you need to write it as 13 minus this.
Yeah.
Yeah? Because remember the formula is that a squared minus x squared?
Yeah.
Yeah? So then you can convert this one into antiderive of 3 over, and then, okay, this is 13, so I'm gonna just take out 3. So that'll be 1 over 30, square root of 13 minus x plus 2 everything squared dx. So now what is u?
Use x plus 2.
Yeah. So then you can prove that du over dx is just 1. So you don't need to add anything else. That would be, so normally this one, I'll put it on the side here. Yeah?
Yeah.
Yeah, I'll just put a note here. So this one is like, move over here on the side.
Yeah.
Right? And then that would be equals to 3. And then remember that you need squared. You need that to be 13, something squared equals 13. So that'll be square root of 13.
And then on the bottom it's squared.
Oh, well, sorry. You don't need it here because it's sine. Remember, sine is just 1 on top.
Oh yeah, 1 over.
Yeah, it's just 1 on top.
Yeah.
And that would be square root. So the easiest is to make sure you write it as something squared.
Yeah.
Right? A squared minus something. That'll be root of 13 squared. And then minus u squared du.
Yeah.
That make sense? The hardest part is the jump from here to here. Okay, that's the hardest part.
Yeah.
Yeah, is to make sure you understand that when you substitute u in here, and the du over dx is a simple, du over dx is simply just 1, which means you can just change from x to, it change from dx to du straight away.
Wait, what happens if it's not 1?
Then we need to make sure we have it. Remember how the last question? We need to actually have it, the negative sin x. Right?
Oh, and then you can just rearrange the.
Yeah, you rearrange it to put it next to dx.
Alright, cool.
And then you have du over dx times dx.
Yeah.
Right, which turn into du.
Yeah.
Okay, so that's a logic jump. These question in example 10, du over dx is just 1. So you don't need, it's just, you can just times 1 at the end, doesn't really matter.
Yeah.
Right? So then this, at this point, you can just use the formula 3 inverse sine of u over root 13. Right? And then plus c.
Yeah.
And what is u? X plus 2. So it'll be 3 inverse sine of x plus 2 over square root 13 plus c.
Yeah. Yeah.
Okay?
Yeah.
Yeah? So the only new thing for example 10 is complete the square.
And that you factor.
Yeah. So complete the square, the idea is that you can turn that into a difference of perfect square. Something squared minus something squared, which is a format of inverse sine, inverse cos, inverse tangent.
Yeah.
Yeah. Or it could be plus.
Plus, yeah.
Yeah. If it's plus, then it will be tangent. Okay. That's example 10. And then example 11 is about linear substitution. Yeah, okay. Alright. Linear substitution. Linear means it's the linear equation. Right? And substitution means you need to substitute something into the equation. Because remember the idea is that when you, I'll repeat the formula here. when you antiderive a function of u, right? Right now it's dx, but if you have du over dx, that will turn into antiderive fu straight away du.
Yeah.
Okay? Alright. Okay, so let's see. Question A. Question A, 2x plus 1 square root of x plus 4. Okay, so the easiest is to go let u equals to x plus 4. Because remember, this is a more complex equation, right? Because this one, the x plus 4 is the more complex one. So that would be 2x plus 1 and then, so this is the complex one, I'll write in different color. X plus 4, everything power half. Okay, power half, that's a bit trippy, right? So, and note that the format that they're saying, the format of these questions is always like, so these questions are always products of powers of linear equations.
Okay.
You see? So that's a linear equation raised to some power and then product with another linear, right? So this one, division is like raised to the power -1. It's like the same thing, right? It's just that raised to the power -1. So same with this one, right? Linear equation to a power, and then here is a linear equation to the power half, right? So products of two powers of linear equations.
Okay.
Yeah. So that's why the linear equation you see a lot of the time. How to you can only deal with linear equations. Yeah. Functions of linear equations. But yeah, so let u equals to x plus 4. So then du over dx is 1. That means you can change straight away.
Okay.
Remember? Right? Because you need that in the expression in order to change that into du. But if this thing is 1, then you don't need it. It's just, you can just change from dx into du straight away if the du over dx equals to 1.
Yeah.
Alright? So yeah. So now we can find that, du over x equals to 1. But this one, so if you were to continue, right? You see that there's a slight difference. So right now, this is still 2x plus 1.
Yeah.
Right? So right now it's dx. But because dx du over x is 1, you can just change the dx into du straight away.
Yeah.
Right? And then this one would be u to the power 1/2.
Yeah.
But you can't solve it because there's still an x here. How do we get rid of this x? Well, the idea is you write x in terms of u. So u minus 4 equals to x.
Okay.
Okay? And then you take this, you substitute this into the x in here. Right? So then you would get, in order to work it out, you need to substitute the x in the x by u minus 4. So that would be antiderive of, now it would be 2 times 2, okay, I'll do square brackets. 2 times, instead of x, you want u. So that's u minus 4.
Yeah.
Plus 1. And then outside is the same, u power half du.
Yeah. Cool.
Okay, so now everything is u. So how do we antiderive this?
You gotta solve for it first.
Yeah, you gotta solve for it first, correct? So antiderive, and then that would be 2u minus 8 plus 1 is minus 7. And then u power 1/2. And then how do we do this? How do we do this one?
Use antiderive it.
Not yet. This is a function times a function. There's no product rule in antiderivative. But,
You just split them up individually, right?
yeah. Well, not yet. You need to expand the brackets because this bracket doesn't have any power, right? It's power 1, so you can just distribute this into each of the terms easily. And then you can combine the power. So that will be antiderive of 2u to the power 3 over 2. Alright? Because u power 1 times u power half is u power 3 on 2. And then minus is just 7u power 1/2 du. Okay? Now it's simply 2 terms. Just antiderive is like antiderive 2x 3 power 2 minus 7x power half. Just rational antiderivative.
Yeah.
Right, add 1 to the power, divide by the new power, so times by 2 on 5, u power 5 on 2,
Yeah.
minus 7 times by 2 on 3, u power 3 on 2, plus c.
Yeah.
Yeah, and then substitute what u is x plus 4. So then that would be 4 over 5, x plus 4, 5 over 2, minus 14 over 3, x plus 4, power 3 over 2, plus c.
And that's it, right?
And that's it.
Alright, cool. That's easy. I get that.
Yeah, you get it, but you can't do it.
Nah, I couldn't do it. But
Right? Just remember, you get it, but you can't do it. You have to go back and practice this.
yeah, I will.
This is very, very tricky. But at least you get it. If you get it, then you can go back and like just watch it as many times as you need until you actually can do the whole question by yourself.
Yeah.
You did redo all the example first before you do the exercises, right?
Yeah.
Okay. It helped?
Not all the examples, to be fair, but I did
Okay.
most of them.
Yeah, but like at least you did like one or two from each example.
Yeah. Or if I didn't get something in there, I'd just go back to the chapter examples, which is the same as these.
Yeah, okay. Yep. Yeah. But remember, my recommendation is still to redo all these examples first.
Alright, I'll do that first this week because it's
Yeah.
getting harder.
Yeah, it's getting harder.
Yeah. Already. Week 1.
Okay, next. Question B. So you see the question B is the same thing. So antiderive 2x plus 1 over 1 minus 2x everything squared dx. Right? So if I were to actually try to work it out normally, I would go let u in the exam, I will let u equals to 1 minus 2x. Right? And then du over dx would be negative 2. Now it's a bit different. Right, now you need negative 2 in the expression in order to turn that into du. Alright, but then after this, I need to make sure x is a subject, so that will be u minus 1 and then divide by negative 2 equals x.
Yeah, that's just rearranging.
Yeah, just rearranging it, right? Okay, so next would be, and then actually, you see this is 2x, so that will be times it back in. Actually, I will change that a little bit, so that would be u minus 1 equals to negative 2x, and then 1 minus u equals to 2x.
Okay.
Make sense? Because the substitution is 2x here goes into 2x here.
Shouldn't they go plus when you put it on the other side?
Sorry?
The other side, shouldn't it go plus?
Yeah, I changed the sign of both of them. You see how u becomes negative, u becomes negative u,
Oh, yeah, I see.
and negative 1 becomes 1.
Yeah.
Alright, and that's how I just times negative 1 on both sides. Okay, so so now I would substitute everything in all at once. If you can follow, it will look something like this. Antiderive, that would be 1 minus u plus 1. Make sense? Because I substitute 2x, the whole of 2x.
Oh, yeah, it makes sense. Easy, yeah, it makes sense.
Yeah? Okay?
Yeah.
And then at the bottom would be u squared, right? But remember, we need to have du over dx. In this case, it's not 1 anymore, it's negative 2. So I need negative 2 in here, dx, and then outside is negative 1 over 2.
Yeah, cool.
Yeah? Okay? I might draw this in a different, write this in a different color so you see the connection here.
Wait, so that whole bottom line just turns to u squared bar.
Yeah, because u is 1 minus 2x. And we want a function of u.
But it's still a 1 minus. Like, see, it's like 1 minus 2x. It's not just.
Yeah, 1 minus 2x is u.
Oh, I see.
I'm doing two substitution at once.
Makes sense, makes sense.
Okay? So that's how you normally do in the exam to save some space, save some lines.
Yeah.
Right? And then you would go, so looking at this is du over dx, right? And this is dx, right? So these two will combine straight into just du.
Yeah.
Yeah? Because that's just the du over dx, so this one connects here. Right?
Oh, yeah.
So that will just turn into du, and now I just need to antiderive it as normal. But in order to antiderive this, I need to remember you split, or actually, okay, let's combine it first. That'll be 2 minus u over u squared du, right? Okay? And then the idea here is the top is just a simple polynomial of u, so just chop it up.
Yeah.
Okay? So negative 1/2, and then that would be antiderive of 2u power minus 2, make sense? Yeah? And then minus u to the power minus 1, make sense?
Yeah.
Yeah, du.
Yeah.
Alright, so antiderive that. Alright, so that would be plus 1, so that would be negative 2u power minus 1. Right, and then after the whole thing will be plus c. What would this turn into?
That goes to 0. What?
No. When you add it to be 0, and then you can't divide by 0, which means the answer will be
Is it the ln one or 1 over?
ln u. Because this is 1 over u. Right, this is 1 over u. 1 over u antiderive is ln
ln
absolute value of u.
Yeah.
Yeah? Specialist, you have to use the absolute one. Okay? Okay. Yeah, and u can't be equals to 0, I'm pretty sure. Oh yeah, they don't specify. I think it's implied. Okay. So yeah, okay, moving on. So that would be just times that in. Negative 1/2 times negative 2 is 1. So that would be just u power minus 1 or 1 over u minus or plus half ln u. And at this point, you can actually substitute what u is, which is 1 minus 2x. Right? And then the u here becomes 1 minus 2x. Change the color. Plus c.
Yeah.
Okay?
Yeah.
Bit tricky?
Yeah, a little bit. That second one was a bit harder.
Yeah, it's a bit harder. So need practice, 100%. Alright? Last one. Okay, last one, example 11c. Techniques very similar, but the working is a little bit different. So antiderive this, dx. Let u equals 3x minus 1. So then u plus 1 over 3 equals x.
Yeah.
Okay? So you see this is x squared. Life is not easy. If it is x squared, my recommendation is if you see that, oh my god, I need to substitute x in here and expand the bracket because it's squared, right? In order to cancel out, you see this one, this is going to be u square root u, right? In order to simplify it, you need to actually expand the whole square. That's what I'm telling you. You need to be very good with expansion. So then x squared would be 1 over 9 times by u squared plus 2u plus 1.
1 over 9, where'd you pull that from?
It's this whole thing over 9.
What?
That's what I'm telling you. You need to be really good with the square expansion. So x squared is this whole thing squared.
Oh, I see.
Yeah, and when you expand the top, you get that. Expand the so over 3. 3 squared is 9.
Oh, this is 9, then we expand the top. Yeah, makes sense. Cool.
Okay. Yeah. So once you've got this, up to this point, then you can just substitute it in straight away. And yes, after this, I need to do du over dx would be 3.
Yeah.
Same thing, you want 3 in there, you times it by 1 over 3, skip a bunch of steps, u squared plus 2u plus 1 over 9, and then times by u power 1/2 du.
Yeah.
Will it make sense?
Yeah.
Yeah? Because the 3 times dx is the du over dx times dx, which is du.
Yeah.
Okay?
Yeah.
Well, makes sense, right?
Yeah.
Yeah. So at this point, when you get up to this point, you know, to do these kind of examples, you need to just get the whole du over dx times dx kind of thing.
Yeah.
Yeah. So yeah, so when you get up to this, just bring the 9 out. That's 1 over 27. Okay? And then times the u in. So that would be u power 2 plus 1/2 is 5 on 2.
Yeah.
Right? And then plus 2 times u times u over 1/2 is 3 on 2. So the power 1 plus power 1/2 is 3 on 2. And then plus u power half. Okay? Yeah, du. Make sense? Okay, get ready for some crazy algebra. This is the last example of 11D, I'm pretty sure. Yeah.
Oh.
Last example of 11D, but this is the most algebraically sweaty one. Okay, so now it's 1 over 27.
Yeah.
Antiderive it would be 2 on 5, right? 2 on 7.
7, yeah.
U power 7 on 2.
Yeah.
Plus 4 on, that would be 5 on 2, so I'll write this one first, u power 5 on 2, and times it by 2 on 5 is 4 on 5.
Yeah.
Right? Plus, that would just be easy, 2 on 3, u power 3 on 2.
Yeah.
Plus c.
Yeah.
Alright? Now, you actually would want to simplify all of this. Yeah? So first, I'll do step by step. First, I'll take out 2. Because the top is 2, 4, 2. Right? 2, 4, 2. So I can take out 2. So that will be 2 over, and the rest is the same, 27. And this would be 1 over 7, u power 7 over 2. Plus 2 over 5, u power 5 over 2. And then plus 1 over 3, u power 3 over 2. Okay, make sense so far?
Yeah.
Right? Now is the sweaty part. You want to take out all of the fractions.
Yeah.
Okay? So taking out all of the fractions is like you're taking out a common factor, which is 1 over 7 by 5 by 3. So what's left behind is going to be 7 by 5 by 3 on top. Right? Because this one would cancel off. Make sense? So if we take out this thing, because 7, 5, 3, there's no common factor. Right? There's the lowest common multiple. You just need to multiply all three of them. Right? Yeah, there's no common factor. So yeah, so if you take out 1 over 7 times 5 times 3, which is 1 over 7 times 5 is 35, right? Times 3 is 105. Yeah, 105. Make sense? And then this one would be 7 times 5 times 3 over 1. So if you take this one out, this is left behind. Alright? So if I'll show you an example, right? So 1 over 7, right? If you multiplied it by this thing, and then multiply it by 7 by 5 by 3 over 1, because we want to take this thing out, right? So if we take this out, what's left behind is 1 over 7 times this. And the 7 at the bottom cancels the 7 on top, which means this will be equivalent to 1 over 105 times by 15.
Yeah.
Does that make sense?
Yeah.
Yeah, so I would take out 1 over 105, so that would be 2 over 27 times by 1 over 105. And the first term will turn into 15u7. 15, u7 over 2.
Yeah.
Okay, think, yeah, this algebra, you need to think hard about this.
So shitty. Yeah.
That make sense?
Yeah.
Because you're taking out 1 over 105, right? And 105 is just the 7 times 5 times 3. Basically, all of the denominators multiplied together. It's the lowest common multiple of 7, 5, and 3 is 105.
Yeah.
Right? So you take that out, then the top is 105, but then when you divide by 7, it's 15.
Yeah.
Right? So instead of actually doing 105 divided by 7, I'm just saying that the top is 7 by 3 by 5, and then the bottom is 7, so it cancels out the 7, so it's just 5 times 3, which is 15.
Yeah, okay.
So instead of doing division, I'm just not doing the multiplication.
Yeah.
Yeah. So what do you think is the next term then? What will be the next term? It will be something u power 5 on 3.
21?
It will be, yes, that's right, it will be 21. Good, you're getting it. And then plus, what's the last one?
What do you think? 35?
Yeah, it will be 35. Right? U 3 on 2. Yeah, that's right. And there's no common factor of these ones. And when you multiply these ones, you just need to do 27 times 105. There's no other way around it. Right? So it's just 27, 105 times 27. So that'll be 35, 7, 0, 1, 2, 2, 8, 3, 5. Okay? So that would just be 2 over 2, 8, 3, 5. And then bracket. Now what is u? U was 3x minus 1. So that'll be, yes. So, actually, yeah. You can take out one more thing. So you can take out, see how everything is over 2. Sorry, it should be over 2. Everything is over 2, right? And you can take out u to the power 3 over 2.
Yeah.
Right? Yeah? So what's left behind then? It will be 15u to what power?
4 over 2?
Yeah, which is 2.
Oh, yeah.
Right? Because 4 over 2.
Yeah.
Yeah? And then the next term will be plus 21u.
Just U, that's it.
Yeah, just u. Yeah. And then the last one will be plus 35. Anything?
No.
No, because you already took it out.
Yeah.
Right? Yeah. And then you would get 2 over 2, 8, 3, 5 of, what was it again? Forgot already. 3x minus 1. 3x minus 1, 3 over 2. Alright? And then here will be 15 times 3x minus 1, everything squared. Do you know what I'm going to do next?
Plus 21, same thing. Plus 35.
Yeah, what am I going to do next?
And expand it.
Yeah, you expand it. Guess it right. Okay? So, yeah, and then this would be just the same. Oh, Make sure everything you have the plus C, otherwise it will be considered wrong. Miss out 1 mark, it's just cascading error. But yeah, so 3x minus 1 power 3 on 2, and that you can actually work it out on the side, right? And just put the answer in. So like you can work out 15. 3x minus 1 squared would be 15 times 9x squared minus 6x plus 1.
Yeah.
Yeah?
Yeah.
15 times 9 is 45 plus, that's 135 x squared. 15 times minus 6 is negative 90x plus 15.
Yeah.
Alright, so work that out, check that answer back in here. 135x squared minus 90x plus 15, and then this one is easy, right? So it'll be plus 63x minus 21 plus 35. Oh yeah, it's just a normal brackets now, and then everything plus C.
Yeah. Oh, yes. Still on math.
Yeah, that's what I said. This is the last example. I don't think you get this example often, but it's good practice for algebra practice. So yeah, 2 over 2, 8, 3, 5, 3x minus 1 power 3 over 2, and then just simplify it. So that would be 135x squared. So 90, negative 90x and 63x can simplify. So that would be negative 27x, right? And then would be 15 plus 35 is 50 minus 21 is 29 plus 29,
45.
and then
Yeah.
plus C.
Oh, wait, isn't it?
No, 35 is 50.
Oh, yeah.
50 minus 21 is 29.
Yeah.
Okay, so that's the answer. 135 minus 27x plus 29. The other one is 3x minus 1.
Right.
Blah, blah, blah. Yeah, that. Oh,
Oh.
I missed something. Plus 36x plus 8. So I got a 2 over 2, 8, 3, 5,
Yeah,
right?
42, that's where it's wrong there, 42. I just got 2 over 5.
Wait, 2 over
Man.
42? Wait, hang on. Ah, yeah. Yeah, that was a mistake. Like this one, when you times it in, it was 21. When you said 21, I was like, oh, that's right. No, that wasn't right. Forgot the 2 here.
Oh, yeah.
It's 2 times 21, which is 42.
Oh.
It's alright. Not too bad. Can fix. 42. So that's 42. Times 3x would be 126. And then minus 42. Yeah, fixable. So that's 126 minus 90x would be 36. Yep, there you go. Plus 36x, and then 1525. Oh yeah, that would be plus 8.
Yeah, cool. Babe.
Yeah, that's a textbook answer.
Sweet.
But yeah, if you get up to this point and made that mistake I made just now, you probably lose 1 mark
Yeah.
out of like 5 or 6. It should be alright.
Yeah.
This kind of question won't be a simple familiar. It will be at least a complex familiar, I think.
Oh, okay.
For Unit 4 exam. But the external, it could be simple familiar.
What?
External,
How can they just change it? But how can I go from a simple familiar to a complex?
because the external one is everything is supposed to be more familiar to you. Like the complex familiar in the internal exam is now more familiar. So it's, simpler.
Yeah.
So basically what I'm saying is that the complex familiar in the external will always be harder than the complex familiar in the internal exam. Always.
Yeah.
Because they have to test more students, so they need to spread you guys out more, and that's why they need to make it harder.
Yeah, true.
Okay, so that's 11D.
Yeah.
Make sense?
Yeah.
Okay, good. Alright, so that's
It
11D.
seems like a lot of grinding and practice.
There's a lot of grinding. It's only 3 questions.
Yeah.
Because every single question you spend that much effort to do 1 question.
That's it.
So this sheet is really short. It's like 11D, it's like that much. I chopped out a few, so you don't have to do some that I think could be a little bit repetitive. You can practice them later at school. That's the idea. But the first pass, just do these initial ones first. Alright, when you get to school, you don't need to do these ones again. Just do the ones I didn't put in here.
Yeah.
Alright, which is normally at the end. So you do at school. I would recommend you to do backward. So instead of doing 2A, you do 2F and then 2E and then 2D.
Yeah. That's
Yeah.
what Sir said to me. He goes like A, C, I, G. Like, so like, he does like
Yeah.
easier than I asked you.
Yeah. But for you specifically, if you have done this one before going to school, you just do it backward.
Yeah.
Because so I would pick like jumping question because he probably trying to avoid repetition like what I'm doing. Yeah. Just that I'm giving you the repetition one to drill you on that, and then you can do the harder ones at school.
Yeah.
Okay. Next is 11E. Substitution.
Wasn't it just the other one?
Yeah, it's almost the same. It's just that this one has definite integral, and there's one new concept. It's not too hard.
It's just like a step thing.
They just keep on adding. Yeah, they keep on adding. Yeah.
Sometimes it's harder, sometimes it's not.
Yeah, this one is not too hard. I think I'll go straight to I won't use the textbook working. I'll go straight to the second example, working for the first example. And so the second example, you see that same working again. So when you see this one, right, the thing you need to pay attention to when you see definite integral is the limits. These are the limits for x, not for u.
Oh.
Okay, so the main concept here is convert limits to be used with du. Okay, convert the limits. This is the only concept you need to remember because the rest is already from 11D. Alright, so first, this one, same steps. Antiderive 0, 4, 3x square root x squared plus 9. Let's change that to power half dx. Alright, on the side, let u equals to x squared plus 9.
Yeah.
Okay? So then du over dx equals 2x. Yeah. See, it's the same thing again. You want 2x and then you give me 3x, so you gotta move the 3 out, divide by 2 times 2, yada yada. But the new thing is, you need to add x equals to 4 and add x equals to 0. What is u? That's the convert limit to be used with du, is this step here. Okay? When x equals to 4, what's u? U is 4 squared plus 9. It's just the definition here.
Oh, okay, that makes sense.
Yeah, 16 plus 9, 25.
Cool.
Yeah? At x equals to 0, u would be 0 squared plus 9, which is 9.
Oh, that makes sense.
Okay?
That's not too bad.
This, it's not too bad. Yeah, this is just the limit for u. Remember, the limit for dx is 4dx. If you want to convert it to use with du, you need to change it to a limit for u. Okay? So then, I can do, this is equivalent to antiderive from 9 to 25 du. Yeah, but remember, in order to get du, you need the 2x here, so that would be 1 over 2. Sorry, 3 over 2. Right, and then you get 2x in there, so that will turn into 2x, right? Yeah. And then 2x times dx is du. Yeah. Right, because 2x is du over dx. Yeah, we went through that before. So then that would be u everything 1/2 du. Yeah, that's it. Okay? Yeah? But look, this 3 over 2 is actually just the opposite. Is it 3 over 2 times by. Yeah, okay. So that'll be 3 over 2. And then when you antiderive that, that would turn into 3 over 2 and times by 2 over 3, right?
Yeah.
Yeah? And then times u power 3 over 2 from 9 to 25.
Yeah.
Right? And then these two cancel off.
9 to 25, yeah.
Yeah, you just gotta work it out. Sub 25 in. Sub 25 in, so that's 25 power 3 on 2 minus 9 power 3 on 2.
Okay.
Okay, so what's 25 power 3 on 2?
I don't know.
Easier than you think. You split the power up. 25 power half, everything power 3.
I still don't know what that is, but what's 25 power half?
Yeah, what's 25 power half? What's power half?
I don't know, is it 5?
Yeah.
Is it?
Yes, it's square root, right? Power half is square root.
Oh, yeah, square root of that. This isn't the other way writing it. Oh, yeah. 5 power 3 minus 3 power 3. Ah, it's 125 minus 27. Oh, yeah.
Yeah.
That makes sense. Oh, that's not too bad.
Yeah?
Yeah, half and then that.
Okay, make sense?
Yeah.
I'm going a full working for you so you can see the actual workings. Okay, so note that in the textbook, what they show you is, So I'll explain this. So what I show you is you need to do the normal derivative and then change it back to x.
Yeah.
And then you substitute the original limits, right? You see this one? Then you put that in here, right? And then you substitute the original limit and you get the same thing.
But that's just so much longer.
It's so much longer, yeah. Yeah, but just remember the limit is for x. So if you can't find u from x, which is weird, most of the time you can. Just that sometimes when you find the limits, I haven't seen those questions yet, but you might get the value where when you sub the x value into it, you get like u equals to root 5 plus 2. And you're like, what? You can't actually work with that limit, right? Root 5 plus 2 is a bit harder to work with than just say 5.
Yeah.
Right? So sometimes you get that, then you might want to just convert it back to x, and then you sub the limit for x in 410 or 40, whatever that was.
Okay.
Right? But for most of these questions, you won't need to. So an example here, example 13, I'll go through these two with the new steps. Just find the limits for you, and then that'll make your answer a lot shorter. Okay, question A. You can go straight, let u equals to cos x, right? And then du over d. Oh wait. Oh yeah. Okay. Yeah, du over dx equals to negative sine x. Right? Now these examples are a little bit different. I'll show you in a second. Question A is a little bit different because in this example, okay, so question A is actually very similar to chapter 11F. 11F, I remember I said at the beginning, is the one that you need a bit of creative thinking. Yeah. And you will need the, most likely, until you've done enough questions for now, most likely you need the formula sheet.
Okay.
You can access it online, right? Just go to QCAA, search for the specialist formula sheet because you will need that.
Yeah.
So anyway, actually I'll grab that.
It's on our OneNote page for school. It's on our OneNote page for school as well.
Yeah. Because you need the trigonometry identities. There's no way you can memorize all of this.
Yeah.
Okay. At this point, there's too much to memorize, so I'm just going to use the formula sheet. That's the only thing that you can probably have to refer to. Okay, so you get up to this one here, and then you would get, so at x equals pi on 2, u equals cos pi on 2, which is?
Just put it with pi on 2 again? Wait, half, so cos is 1. Wait, no, cosine 0.
Let me double check something. So 2 cos squared. Yeah.
0, right?
Yeah, 0. And then at x equals to 0, u would be
1.
Yeah, 1. Cos of 0, which is 1.
Yeah.
Alright, okay. So then, now, but the thing is, this one, du over dx is negative sine x, you see? But there's only cos cube x. So how do we get the negative sine x in there?
You have to derive. Oh, you use anti-derive the cos, derive the cos, so that you get it, and then you times negative 1 in, right?
Hang on, sine cos. No. Actually, no. My bad. You have to change it first to know which you let to be u, because right now it won't. U won't be this thing. I just realized u won't be this thing. Okay, so let's change that around first. Actually, so antiderive from 0 to pi on 2 of cos cube x dx. The idea is and this is actually the idea of 11F, is you change the power 3 into cos squared x times by cos x.
Okay.
Yeah, dx.
Yeah.
Okay?
Yes.
It will be like this. Right? Why? Because use the identity in here, that's cos of use cos squared x plus sine squared x equals 1. So then cos squared x would be 1 minus sine squared x.
Yeah, okay.
Yeah? Okay? So then you substitute that in, so that the top function would be equals to antiderive 0 to pi on 2 of 1 minus sine squared x times cos x. So actually, in this case, u would be sine x.
Yeah, okay.
Yeah, and du over dx would be cos x instead. Okay, so this one would be sine of pi on 2 and sine of 0. So sine 0 is 0, sine pi on 2 is 1. Yeah, that makes more sense. Yeah, it will be from 0 to 1. Okay, make sense? Yeah. So this is, and remember, this is just u equals to sine x, so you just want a function of u, right? And you already have the du over dx in here. Right? This is literally your du over dx here, right?
Wait, this is a quick question. I get the identity, that theorem equals 1. How did you sub it in there, Bob? Because it's just cos squared. Oh, you just rearrange.
No, I literally just put this thing into where cos squared is.
Yeah, but you rearrange them on, yeah. All good.
Yeah, just rearrange it, yeah. Okay, so yeah, so that would be, now this thing would become du, right? Because that's du over dx times dx, which is du. Yeah? Okay, and then 1 minus sine x squared, sine x is u, so that'll be 1 minus u squared du.
Okay.
That make sense?
Yeah.
And what's the new limit? It's no longer. So right now this is du, so you can't use the limit for x anymore. You have to use the limit for u, which is 1 and 0.
0 to 1,
Yeah?
yeah.
Okay. So then that would be antiderivative would just be u minus u cubed on 3 from 0 to 1.
Yeah.
And that's it. That's pretty simple.
It's not hard getting to it. Once you get to it, it's easy.
Huh?
It's just hard like formulating the steps
Yeah.
to get to it.
Yeah.
Then after it.
After that, when you get to that point, it's easy after. But the hardest part is is formulate from here to here, and knowing that from here you get to this.
Yeah.
That 2 steps, step 1, step 2, those 2 steps are the hardest.
Yeah.
But after that, it's antiderivative. Yeah, that'll be just 1 minus 1 on 3, which is 2 on 3. Very convenient answer.
Yeah.
Yeah?
Cool.
Okay, so that's A. And then B is easier. B is easier. When you see trigonometry, you start sweating. Okay? And tell yourself, I gotta be very careful. But when you see exponential, easy stuff. 2x squared e power x cubed dx. Okay? Let u equals to?
X cubed.
Yeah, so then du over dx is 3x squared, right? At x equals 1, u equals 1. At x equals to 0, u equals to 0. So the 2 limits map exactly the same.
Yeah.
Well, so then, so next would be, now we want 3x squared. This is 2x squared, so you need to take it out, 2 over 3, and then you will get 3x squared, alright? If you want to be sure, you can do the 3x squared here, alright, and then times by e power u dx. If you want to be sure, just write the step.
Yep.
Okay, and then the next step, you can turn that into 2 over 3, and then antiderive from 1 to 0 of e power u du. So that step is the safe step. You might get marked for this. Okay, I'm just skipping it sometimes to just get through the question, but you should write the step to convert the du over dx, because that's part of the formula. Okay, anyway, so that'll be 2 over 3, and then e power u is exactly the same. That's just e power u from 0 to 1.
Yeah.
Yeah, so that'll be 2 over 3, and then e power 1 minus e power 0, just that. 2 over 3 e power times e minus 1, yeah.
Yeah, easy. Makes sense.
Okay,
Yeah.
makes sense? Yeah, that's it.
There's one question, but it's what?
Yeah, but it's like M, like how, no, like
Yeah.
13 parts. Yeah, because you need to do a lot of practice, like converting some of the limits. So note that question M. Okay, some of these questions you may not need to use the new rule, because remember they throw in questions where sometimes you need to use a new rule, sometimes you don't need to use a new rule.
Okay.
Okay?
Yeah.
Yeah? So watch out.
Alright.
Just watch out. Sometimes throw in a question that looks hard, but actually if you just apply the basic rule, you can work it out.
Yeah.
Yeah, so just watch out for that. Okay, next is 11F.
trig identity.
Yeah, that, as I said, this one you need a lot of creativity and need to understand how to use how to use the formula sheet.
These ones.
Yeah, the geometry identities are these ones here. Double angles, angle sum and difference, product identities. You're gonna know which one to use. That's what I'm saying. Yeah, be a bit creative. Think about, okay, which one am I gonna use to do it. Alright. They do teach you a new concept, so I'll go through this one. When you have an antiderivative of a sine, a power of sine times the power of cos, there are a few cases. So the first two cases are very similar. Both either the power of sine is odd or the power of cosine is odd. Okay? And the idea is that if it's odd, you turn that into 2k plus 1. So then you get sine squared to the power k and then times sine. Then sine squared is 1 minus cos squared. Remember what we did earlier?
Yeah.
The one where sine squared plus cos squared equals 1, right? Yeah, so sine squared is 1 minus cos squared. Yeah. And then this one, then you can go u equals to cos x, because then u dash or du over dx would be negative sine x, right? Which is what's sitting outside of the brackets. Yeah, and that's the same for when the power of cosine is odd. Okay? But when both powers are even, right, then either you use this or this can be used. And also you need to remember to antiderive sec squared give you tangent.
What? Yeah,
And then tangent squared equals sec squared could also be used. You have to just know which identity to use. That's what I'm saying. You have to practice all these questions, and then hopefully in exam you'll be like, I think it's gonna be this one, and then you get it right.
Alright.
Okay?
Yeah.
So yeah, as I said, this part is you need a bit of creativity. There's only one example. 14. 5 questions.
What?
They look simple, but they're not. Okay? You need to know what to use. And I think there are potentially multiple ways of doing it. I think. So I'm going to attempt to use whatever I'm guessing, to do this identity and see if I can actually work that out. Okay, it might be different from the textbook example. Okay, let's start with question A. Antiderive cos squared x dx. Okay, what do you think we'll use here?
Can't remember. Probably the sine one, bro. Either A or B, I reckon it's an easy one.
No, this one, the one that we're using is cos 2a equals to 2 cos squared a minus 1. Okay, rearrange it. Cos 2a plus 1 divided by 2 equals to cos squared a.
Oh, okay,
Yeah, because the idea is you want to get rid of the square as much as you can. Either you get rid of it or you turn it into like the whole thing where you can do du times du over dx times dx.
Yeah.
Yeah. So in this case, you can get rid of the square because you can antiderive cos 2a. Right, it's just 1 over 2 and then sine 2a. Yeah. So then this one would be antiderive of. I put the 1/2 on the side, and it'll be cos 2a plus 1 dx.
Okay.
Cos 2x, sorry. Plus 1 dx. Yeah? And when you antiderive it, it's just this basic stuff. So cos becomes, so that'll be 1/2 and then sine 2x.
Yeah.
Yeah? Because derive sine, you get cos, antiderive cos, you get sine.
Yeah. Plus sine, yeah.
Okay? And then plus x, plus c.
Cool. Yeah?
Yeah? Make sense? 0/2, yeah. So that'll be.
Just 1 over 4, right?
Yeah, 1 over 4 sine 2x plus x over 2 plus c. Or you can go right, plus 1/2 x, same thing. Okay, let's see. Textbook answer, yeah, that's right.
Cool.
Okay? And then question B. Tangent squared. So you want to get rid of it? Tangent squared would be sec squared minus 1. Okay, let's see. So question B, right? Antiderive of tan squared x. So tan squared, we're using the identity tan squared x plus 1 equals to sec squared x. So then tan squared x would be sec squared x minus 1.
Okay.
Yeah, okay. 1 over cos squared, yeah, okay. So that would be antiderive of sec squared x minus 1 dx. Yeah, and that was a antiderivative rule that said something like antiderive sec squared is 10. Okay, yeah, so this one would just be 10x minus x plus c.
Okay.
Yeah, because when you antiderive sec squared, you get 10. It's one of the calculus rules here. Okay, so 10x minus x plus c. Yeah, question B. Okay, so yeah, now moving on, question C. Antiderive of C is antiderive of sine 2x cos 2x dx. So looking at the identities, right, see which one has sine times cos. This one, sine 2a, so the one I'm using is sine 2x would be 2 sine x cos x. Right, looks similar but not the same. This is 2x, which means I need to find sub x equals to 2x into both equations. Instead of x, I want to go with 2x. So that'll be sine 4x equals to 2 sine 2x cos 2x. So you see, you have to manipulate the identities. That's why you need a bit of creativity in these questions. And then you want just this thing, so you divide both sides by 2. So this is half of sine 4x would then be equals to whatever you want.
Yeah.
Right? So then that is the same as antiderive. And remember, the idea is you get rid of any products of sine cos and just turn it into the 1 sine or 1 cos. So you can antiderive just sine of a linear function. Right? So that'll be 1/2 antiderivative of sine 4x dx.
Yeah.
Yeah? And then you can antiderive it. Sine is negative cos, so it'll be 1/2 of negative 1 over 4 cos 4x plus c.
Yeah.
Yeah? So that'll be negative 1 over 8 cos 4x plus c.
Yeah.
Let's see, negative 1 over 8 cos 4x plus c. Yes, that's right. Okay?
Yeah.
Okay, all right. Next would be antiderive cos power 4 of x. Okay, all right, let's see. Okay, question D. Antiderive cos power 4 of x. Look at identities, there's nothing, right? The maximum you can do is cos squared. Yeah, cos squared like the one that we used earlier. So, which means the best thing I can do is to go antiderive of cos squared x, everything squared, dx.
Yeah.
Right? And then given what we found earlier, so cos squared x, we change that one around, that will be cos 2x plus 1 over 2. Right? So we'll give this one, chuck that one in there.
Okay. And split square, yeah.
Yeah. Yeah, so chuck that one in there and split the square up. So okay, actually I'll do it step by step. So then that would be equals to antiderive of cos 2x plus 1 over 2 everything power 2 dx, like so. Expand the brackets. See why you need to be good at expanding brackets now. Yeah, so that would just be over 4. So I'll just take out the 1/4 over here.
Yeah.
Yeah, 1 over 4 antiderive, and then this would be cos a squared plus 2ab plus b squared. Right, so cos squared 2x plus 2 times a times b, so 2 cos 2x plus b squared, which is plus 1 dx.
Yeah. Yeah, 2ab plus b squared, yeah.
Okay, make sense? So it's cos 2x everything squared. Okay, yeah. Alright. So okay. So up at this point here, let's see. So now we need to get rid of this thing, cos squared of 2x. So it's cos 2x and then everything squared. Let's see which one I'm going to use.
Like a double one.
Cos squared is I feel like it's the same one again, but yeah, let me check with the textbook a little bit. Once you've done a few, you have a bit more confidence. So cos power 4 is 1 over 4 times the... Oh, they actually just repeated it. Yeah, no, they just repeated it. Okay, so the idea is that this one is cos 2x everything squared, right? So, because this is this one is cos x everything squared. I'm just replacing let x equals to 2x. Alright, so I'll get cos of 2x everything squared, which is this thing. Yeah, that would be equals to cos of 4x plus 1 over 2. Does that make sense?
No, where'd the
It's 2 times 2x. So instead of x, I replace x on both sides with 2x.
Okay, I think I get that.
Yeah, so then, so this is cos squared 2x would be the same as cos 4x plus 1 over 2. Okay, alright, make sense? Put that one in one more time. That will be 1 over 4 antiderivative of cos 4x over 2 plus, I'm just going to split that up, plus 1 over 2. Yeah? And then the rest is the same, plus 2 cos 2x plus 1 dx. Okay? Now we can derive it. Yeah? So 1 over 4 outside everything, and inside would be cos is sine 4x over 8. Make sense? Yeah? And 1 over 2 plus 1 is 3 over 2, so it'll just be at the end will be plus 3 over 2x. Yeah? Plus c. Now it's need to antiderive this thing. So plus 2 over 2 sine 2x. Yeah? Let's do it one by one. Alright. Let's see. I think the textbook would probably they'll probably keep it. They actually take out 1 over 8, I think. But yeah, so the next step, I'll just simplify it first. That'll be 1 over 8 sine 4x, and then plus sine 2x plus 3 over 2 times x plus c. So then I'll take out 1 over 8. See this one? 1 over 8, and this is 3 over 2. Alright, and this is 1. So I'll take out 1 over 8, so that'll be 1 over 4 times by 1 over 8. What do you think is so the coefficient of sine 4x is just simple, alright? It's just sine 4x. What's the coefficient of sine 2x? What does it become? You take out 1 over 8.
Is 8, just 8?
Yeah, very good. Just 8. So 8 sine 2x. And then if you take out 1 over 8 from 3 over 2, it's like you're timesing 8 in. Alright, to balance it out. So that will be
12?
Yeah, plus 12x plus c. So that'll be 1 over 33. Sorry, 32 times that. Okay. See if they actually didn't take out the 1 over 32. This is times back in. Yeah, but same thing. Okay? If you take out 1 over 32, you get the same answer. It will be 8 sine 2x and then 12x plus c. Yeah. Same thing. Textbooks sometimes inconsistent. Sometimes they take out the common factors, sometimes they don't. I'm like, why? Well, but yeah, does it make sense?
Yeah, it makes sense.
Okay. So actually, I think when I was checking this question with the textbook answer, it was really confusing. So don't look at this textbook answer. Okay, don't bother with this textbook answer. Just go with my answer.
Okay.
Right, it's the same strategy, but the substitution I wrote on the side here is easier to understand. You just put it straight in and then expand, and you work it through.
Okay.
Right, the textbook one is a bit confusing. Don't bother with it. Now question E. Sine cube x cos squared x. Hardest one. Antiderive sine cube x cos squared x. Okay, which scenario?
Probably the
The 2k plus 1.
density one.
No, this is the one where it's trig times trig.
Surely you can just go sine squared x, cos squared x, sine, and then just sine x, and then it's that, and then sine x.
Yeah, no, you're on the right track. Yes, you do. You split that into this. That's right.
Yeah.
Right, and then sine squared x turn into
1.
no 1 minus cos squared x.
Oh,
Yeah, the identity is the
yeah. You
The-
swap the sides. Sine squared, cos squared equals 1.
yeah. So that's the identity, and then that will be times sine x times cos squared x dx. But because you have sine mixture of sine and cos, but then you see if I let u equals to cos x, then du over dx would be negative sine x.
Yeah. Okay.
So this is when you would use a substitution, because you can't just simply just get rid of them, right? So yeah, and that's what I'm saying. Sometimes you might need to. Yeah, it's a bit of it's a bit sweaty. Yeah. Okay, and note that if it's definite integral, you need to convert the limits to the u limit for u, all that shit. All right, so yeah, so that would be antiderive of 1 minus u squared, all right? And then in order to get negative sine x, you need to put a negative there, and then you need negative sine x in here, all right? And cos squared x is just times u squared dx, all right? Now this thing with this thing together would turn into du.
Yeah, so it like cancels.
Like the same thing, right? So minus of, and now you times the u squared into the bracket, so it'll be u squared minus u cubed, sorry, u power 4 du.
Oh, yeah.
Yeah? Because those two things turn into du.
Yeah, cool.
Right? So yeah, so that would be minus of 1 over 3. Oh yeah, I'll just times minus back in. So 1 over 3 u cubed plus 1 over 5 u power 5 plus c.
But now it's going to be hard on yourself.
No, u is cos x, so it's just, minus 1/3 cos cube x plus 1 over 5 cos power 5x plus c.
Yeah.
We already antiderived it, so.
Yeah, cool. How was that one the hardest? Oh, probably because
There.
yeah.
The hardest because of the
Substitution.
yeah, like when you see that in the exam, if you don't recognize the two, so remember, if you have, so remember the main trick is the main theory of this chapter, right? Because all the other one is just using trig identity. So the practice is that, you should know trig identity. You should be able to use one of these things, right? One of these things to solve this one. But if you can't, then the formula you need to remember is when you see antiderive sine mx times, right, times by cos nx. So basically, it's a product, right? When you see product of trigonometry, product of sine or cos functions.
You have to do like the substitution.
Yes, you need to you need to consider if m is odd, right? If m is odd, then m equals to 2k plus 1.
Oh, yeah.
That's all.
That is 2k plus 1. Oh,
Yeah, because 2 plus 1.
Yeah.
If you have a harder scenario, it's like I don't think you see it in this chapter, maybe in the review, but in the exercises they actually don't give you something harder than that. They tell you the theory, but they don't give you like cos power 11. They don't give you that. No, they just give you cos power 3, or sine power 3, which is that one. So it's just sine squared times sine, easy. But if it's sine power 11, then that'll be sine power 10 times sine. And sine power 10 is sine squared power 5.
Yeah, okay.
Right? And then you would get like 1 minus cos squared, and then there would be like a power 5 here.
Yeah.
Does that make sense? If this is like power 11.
Yeah.
Yeah, then it will be like a power 5. Then at the very end, you can't actually times this one in. You have to like, I think, leave it on the side, and then, yeah, I think it's a bit complicated. Yeah, you need to expand the brackets and stuff like that. So I don't think they will give you something too hard. Most likely, the maximum they will do is power 5. Okay? If this is power 5, then you would get sine power 4, which is this thing sine squared, everything power, it will be like everything power 2, and then times sine, right? Then you get a quadratics at this point, and then you have to expand that before you times the u in.
Yeah.
I think that will be like the max that they would give you.
Surely, right?
Yeah, surely they don't give you anything harder than that. If you get power 4, it's like a really long question, but you know, it's just expanding polynomial.
Yeah.
Like that's not part of specialist, that's methods.
Yeah.
Yeah. So hopefully you only get squared. That's what I'm telling you. The a minus b everything squared, a plus b everything squared. In specialist, you see that so many times. You have to be so good at it. At the moment I ask it, you'll be like, oh yeah, that's, you know, I know the expansion. Right? Do this question and you will have to get good at it. There's no choice.
Yeah.
Okay? So yeah, so that was the end of E.
How many
And that's it.
how many chapters are in it?
9 chapters.
What?
So we've done 6 so far.
Oh,
There's 3 more.
Still sweet.
Okay?